Hey, we back. So we're on these here challenges again, as you can see here. Doesn't that look funny? Last time we did the word search, which was actually like a thing, right? That's like word searches are things that people know about, and we have now entered the realm of I want to say the realm of fantasy. It does literally exist, so I can't really say that. But the realm of stupidity, I guess. Because this isn't really English, is it? Yeah, it's not really English. And yeah, we each kind of goes on for a bit about lambda calculus and beta reduction. That sounds fun, eh? And basically we get handed this, which handily doesn't really explain what these actually mean. So that's great. Long story short, the macro thing here, that's these, right? That's why it's just a string, right? Because it's just the letter G. Application, as you can see, this one's fairly self-explanatory, I figure. Is just two lambda expressions next to it, basically. Next to each other. So you see, this is three next to each other, three things. This is one, and this is one. So that's two applications there. This applied to this, and then these two together apply to this. Maybe the other way around, I can't remember. That. Lam abs, which is... can't remember, to be honest. I always think it's absolute, but it's not absolute. Abstraction, that's the word. There we go, abstraction. So we've got lam abstraction, that's basically the arrows. Right, so you've got y in this thing, and x in this thing, and whatever, right? So that's that. And then lam var, that's just the x and the y, right? Variables. They're ints here because instead of being x and y, we would have 1 and 2 in an actual one with this. So that's kind of annoying that they did that, but sure. It's also kind of annoying that they randomly swapped something around at some point? I can't remember where it was, somewhere around here. They swapped the x and the y around, which was right annoying. It took me a while to figure out that one. But yeah, anyway, there you have it. So that's the example, and then what we're taking these thick expressions here and turning them into nice ones. So that's what we got for the third challenge. Now I looked at this yesterday, and I thought, wow, that looks very stupid. Like, considerably stupid. Stupid enough that I don't really want to do that. Obviously, I did it anyway. But what I was struggling to understand is actually what it meant, not how to do it. So I thought I'll sit for a bit. I'll just try and work out what we're doing, and then we'll actually try it. And I'll get the recording up, and I'll actually try it, right? And yeah, basically that didn't happen because in trying to understand it, I wanted to test how these are actually constructed. What does this actually mean? Because you look at this is kind of weird. From my perspective anyway. You've just got a bunch of stuff. I mean, you know, it's kind of hard to describe because I know what it means now because I spent the hour or whatever just kind of staring at it. And I just tried to construct some of these and work out in my head what it'd be like here. And with the brackets, why does it need the brackets? Where does it need the brackets? I was asking things in Discord about it, like what's the difference between this one and this one? Or what difference does the brackets make? Because I was right proper confused, to be honest. But we got it figured out. In the process of doing this, I thought we'll start up. We'll get some of the program written, not like actual program, but like test stuff, right? We'll get some test stuff written, so that we can see how it's going to work. And turns out, actually, once you figure out what all of this means, it's pretty easy to actually write the program. So it took me about 20 minutes, and I accidentally kind of did it before actually starting the recording. So what I'm going to do is I'm going to give you a quick walkthrough, quick explanation of what all of this means, and then after that we're going to move straight on to challenge 4, which, looking at this, is basically just the opposite, right? You take the nice looking ones and you turn them into this instead, right? So it's just kind of backwards. So hopefully it's not too hard. I don't actually know though. But yeah. let's give a quick explanation of this one. So if you come and look over here, we have our program. So let's start off with the easy bit, which is what's the easy bit? It looks like a bit of a mess, and that's mostly because it is a bit of a mess. This is just the testing thing that I did. We'll get to that. Should we start at the bottom or at the top? Let's start at the bottom. So first of all, this is the actual pretty print function, right? As the instruction says, it takes a lambda macro expression, returns a string. So we take lambdef, which is, if you recall, back up at the top we had our this thing. That was in the instructions. So we have lambdef is the lambda macro expression thing, and then lam expression is these things that I went through earlier, right? So where were we? This takes we split it into macros and expressions. So this is a list of macros that will be, defined basically, and then this is the expression that you're actually working with. So first we print the macros using the function print macros. Makes sense. And then you add that onto print expression. You also pass the macros to this, which I'll explain later, but then also the expression. So that's basically just splitting it up into two separate functions. Probably not necessary, but I thought it'd be a bit cleaner like that. And maybe it was necessary because this one is recursive, so whatever. In fact, I think they're both recursive. Fun. Anyway, that's what we had with this one. Print macros is pretty simple. Obviously, yeah, it takes a list of strings and lambda expressions, which I explained. So this is the names. So it is pairs, right? So you have a name for the lambda expression and the lambda expression itself, and then there's a list of them, right? And it returns a string. So base case, this is when you pass it. There are no macros defined. It just returns nothing, right? And then basically for each macro split into its name and its expression, this is basically this is the return, right? This is what we're printing out. So it prints def spacebar. It prints out its name spacebar equals spacebar. This is just the format that they asked for, right? Then it prints the expression, which is this thing here. We'll get to that, but yeah, it just prints the expression. No macros. So like I said, it does get past the macro here, but in this scenario it's not past any macros. So it prints just the expression in the macro, it adds in, and then it prints the rest of the list of macros, right? Because it is a list. So this is print macros again, so this is why it's recursive, and then it'll keep printing out each macro and adding it on with the in on the end until it runs out, and then it'll just return nothing. So this gets shoved on the front here. And then if you go one up, here we have the long function. Let's just quickly go over this one because this one's short. Get macro name. This basically, again, it takes a list of macros, the list of macros that are defined, and it also takes a lambda expression. It returns a list of strings, right? So this is the macros and the expression to find. So basically you're looking, what this does is it checks if the lambda expression that you've given it is in this list, right? And if it is, it returns the name. It returns the name, right? So I've done this with a list comprehension. So it returns the name. Like I said, technically it returns a list of names because you could theoretically have the same macro defined multiple times. So we take head of this when it's actually called here, but I'll get to that. So we return the name from the pair name expression from the list macros, right? Where the expression in the macro is equal to the expression to find. I feel like that kind of makes sense. It's a pretty simple list comprehension of all the list comprehensions that exist, but personally I find this comprehension a little confusing, so it did take me a bit of time to put it together. I say a bit of time, 5-10 minutes maybe, not too long. For Haskell stuff, that's not too bad. Actually, no, that's probably an exaggeration. It didn't take me that long to do it all. It took me a couple of minutes to get this going. That's the point. It was not super short, but it wasn't too bad because it is quite a simple one. But yeah, it just checks the list of macros and then just checks, is the one you're looking for the same as the one in the list? And if it is, return its name. And yeah, theoretically, you could get multiple of the same name, but it would be the same name. It should be the same name. What you could have, I suppose, is if two different macros had been defined with different names, it would return the first one. But that's how it had been specified in the instructions anyway, so that's fine. So now we get to the big one, print expression. It takes the list of macros, the expression you're trying to print, and returns a string. So yep, macros, the expression. So first what it does is it checks the length of getMacroName. You see this? If it's more than 0, as in there's something in the list, take the first one head and just return that, right? Return the head of this, right? So basically what this line does is it just checks if you just give it a macro as an expression to print out, then it's going to print out the macro instead of printing out the whole expression, right? Which is why down here we pass nothing in the list to print out the expression in the macro, because otherwise what it would do if you actually passed it macros in here, then it would print out like f is defined as f or whatever, right? Which obviously we don't want. Then we have a simple one. If we just check what type of expression. What's it called? I can't remember what this is. What this type of thing is called. Am I stupid? Probably. That's normally how it goes. Let me just find what it's called, because I know someone said this recently-ish. Here we go. Pattern matching. That's the one. That's the word. Pattern matching. I'm really good at Haskell, guys. It's just so good. So yeah, we pattern match the type of expression that you're doing. So if it's just a variable, we've got an easy one. You just print x, and then this is an integer, remember? So we print x and then the integer. So what we get is x1, x2, x3, so on, instead of like xy, like in that example that I showed you. So that works fine. Then if you've got an abs, again, this is not too difficult. You print the backslash with an escape character. If you just have the 1 here, basically, long story short, it doesn't work. It's not escaped properly, so fun. But with 2, it's fine. So yeah, we just escape it because we want to actually print out a backslash instead of having it used as a fancy character. So yeah, we get backslash x. We show x, so this is the same as this, and then we add on the arrow, which is what I talked about before, and then we just print out the expression that's after the arrow, right? So because the lamabs is passed with x and an expression, so we print out the x with the arrow and then the expression. Works fine. Application is where it gets difficult. So I've basically created a lookup table here. Application is expression, if you remember. So I have expression and we have expression 2, right? So what we do here is we have lamvar with lamvar, lammacro with lamvar, lamapp with lamvar, lamabs with lamvar, and then lamvar with lammacro with lookup table. 16 results here. As you can see, they're all there, and they're all just fantastic. Most of them are pretty simple. If you've got a lamvar with a lamvar, you just print the lamvar with the lamvar. Easy. And what I could do, because it is just a lamvar, I could just put this in here, but I thought let's make it actually consistent, print out the expression. So yeah, we just basically we recurse, you know, print out each expression, and it is just going to return this here in place for these, and that's going to be simple. It probably would be faster if I put this here, but I doubt it's exactly taking much time to do that, and to be honest, I just don't really care, so I just did it like that. Plus, it was very copy-paste-deable, so that's nice. The same with most of these, lam macro with lamvar, lam app with lamvar, so on. But here we go. If you've got a lam abs and then a lamvar after it, what we need is we need some brackets. Right, you need brackets around the lam abs because of the way that this works. This is basically, I just had to create a bit of a lookup table, right? But yeah, if you have lam abs and then lamvar, you need brackets on the first one. That's just how it works. But here's the real rub as well, because if this is a macro, if we print this and then we get the statement here where it's a macro, then it would just put here as like F or something. But we've already added the brackets, so you're going to have just like brackets and then F. And that doesn't make much sense, right? This is not what we want. So we have to first have a guard that checks the macro name of the expression is less than 0. More than 0, sorry. If it's more than 0, that means that this is a macro. This first one, it means it's a macro, so you don't need the brackets. And then if it's not a macro, we add the brackets. Right. And then that's the same with all of these. So you see with the guards, they're all the ones with brackets where you check if it's a macro first, and then if it's a macro, you just print it out, and if it's not macro, you add brackets. And yeah, you can see some of them need guards and some of them don't. Most of them don't. It's these ones that get really silly, where you've got lam app second. They all need a guard, and in fact, lam abs and then lam app is the really silly one, because actually that would be bracket. You see, you have bracket around the first one and bracket around the second one. So what you need to do, what I do anyway, I check if both of them are macros, in which case no brackets. Then I check if the first one is a macro, in which case brackets around the second one. Then I check if the second one's a macro, in which case brackets around the first one. And then if neither of them are macros, brackets around both. It's very silly, basically. Then we have at the bottom with lam abs second, and as you can see, there's this one needs brackets around the first one. I'm pretty sure this works. I did some testing and it seemed to return correctly on all the results that I gave it, so I'm pretty sure my lookup table is correct. I feel like there's a more efficient way of writing all of this. I did think maybe, say, if all of the lamvars didn't need brackets, you could just shorten this one down, right? But no, you totally can't. Because the point is that then it doesn't matter which of these it is. You could just have lamvar here, but you know, one of them needs brackets. What I could do is I could say, okay, this is the one that needs brackets, so we check if it's a lam abs. Then if it's a lam abs, do this, and then if it's not a lam abs, do something else, right? So instead of having is it a lamvar, is it a lam macro, is it lam app, you could just have lam abs, not lam abs. You'd have 2 statements instead of 4. That would be shorter. But to be perfectly honest, I don't think it makes too much difference. It's, in my opinion, maybe a bit more readable like this because you have the nice pattern. And yeah, you could have lam abs and not lam abs, but that might not be initially obvious, right? You do check for lam abs and then you just check for lamvar in place too. It's not obvious that you've successfully written out all of the cases. And so while it would be actually considerably less code, about half the lines of code for all this, probably, something like that, but I don't think it's actually as readable, as obvious what's going on, you know, and I kind of like it like that. I like to know what's going on, right? So so I just left it. I thought that'd be fine. Whatever. I guess it's opinionated at that point, really, isn't it? And then finally, we do have at the bottom, of course, You forgot we were actually checking this, so all of these are LAM apps originally, and you're just checking what you're applying to what. If it is a LAM macro, then this is the easiest one of all. You just print out the character. You don't even need, with all this, with the show and the X, it's just print out the character. So that's simple. So I think we've gone through everything now. Let's just go over the testing that I did. So if we nip over to here, you can see the testing that I was running. This is one that I was trying to run for ages. You see the errors, that's actually because I was inputting it incorrectly, not because of anything else. So this example you might recognize, that's the one in the sheet that I managed to write out myself with all of this mess here. And that's the one that was, that's this one here. I ended up writing it out here just to make sure it was correct. Took a while actually to write that out. But you notice that this is the one that we had in the sheet. We've got G, X1, X2. The X1 and X2 is replaced for X and Y, but other than that, it's exactly the same. And then we had a couple of other examples as well. So if I go up a bit, here we go. We had things like this, which prints out that. This is the stuff that was in the table, right? So if you remember back to the table, we had... are we at the table now? Yep, wonderful. Here we go, we had things like this. So this is the one that I just ran here. It's saved in the program as a thing, and this is the output that the program gives. So basically it's working. So that's fantastic. Exactly as we wanted. As they wanted. As the task wanted. The challenge. So yeah, now we're on to this one, where basically I'm doing the opposite. That took a lot longer to explain than I had anticipated. But I think that's probably a good thing, because that means I've given a fuller explanation. Hopefully it's actually understandable now, which is going to be nice. Yeah, it would have been nice to code this up on camera and get it all uploaded. But yeah, like I say, I kind of wasn't expecting to do it yet. I was just trying to test stuff, and then I was like, hey, maybe this would work. And then it did work. So that's great for me, but not so great for the YouTube. Anyway, it all worked out. So now we will move on to challenge 4. However, given that the video has been a bit over 20 minutes now, I think that's plenty long enough for a video, to be honest, which I wasn't really expecting, but yeah, like I said, I guess stuff just happens. So I will actually split this up into 2 videos after all. We'll have this one as one, and then tomorrow you can see the challenge 4 being done. Bye!